Welcome to Balaya Math Lectures. Learn every step. Today, let us solve one more problem on finding eigenvalues and eigenvectors of a matrix. Here is the problem. Find the eigenvalues and eigenvectors of the matrix. A is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. How can we solve this one? First of all, we need to write the characteristic equation of the matrix. Let the characteristic equation of A is that A minus lambda I equal to 0. That means you need to subtract lambda from the diagonal. That means 6 minus lambda minus 2, 2. Minus 2, 3 minus lambda minus 1. 2 minus 1, 3 minus lambda is equal to 0. Let us expand this determinant. That means that implies 6 minus lambda into, you need to remove the first column and first row. So 3 minus lambda whole square minus 1, which is lambda square minus 6 lambda plus 9 minus 1 plus 8. Minus into minus plus 2 into, you need to remove the first row and second column. Minus 2 into 3 minus lambda, that means 2 lambda minus 6. Minus to minus plus 2. Plus 2 into, you need to remove the first row and last column. So minus 2 into minus 1, 2, 2 minus 2 into 3 minus lambda. That means 6 minus 2 lambda equal to 0. Let us simplify this one. That means I am multiplying this with 6 with all of the items of this one. That means 6 lambda square minus 36 lambda plus 48 minus lambda cube plus 6 lambda square minus 8 lambda, and minus 6 plus 2 is minus 4, minus 4 into 2 minus 8, 2 into 2 2 lambda plus 2 plus 2 into 2 4 lambda, 4 lambda, and here is also minus 4 into 2 minus 8 plus 4 lambda equal to 0. Let us simplify again with the higher powers of lambda. That means minus lambda cube, 6 lambda square plus 6 lambda square plus 12 lambda square minus 36 lambda minus 8 lambda plus 4 lambda plus 4 lambda. That means minus 8 lambda plus 8 lambda will be cancelled out, minus 36 lambda. Here it is minus 8 minus 16. So 48 minus 16. 48 minus 8 is 40. 40 minus 8 is 32. So plus 32 equal to 0. Let us multiply the equation with minus. That implies lambda cube minus 12 lambda square plus 36 lambda minus 32 equal to 0. To find the roots of this cubic equation, let us use synthetic division or Harness method. Here it is. You need to write the coefficient of higher powers. The quotient of lambda cube is 1 and lambda square is minus 12 and lambda is 36 and the constant is minus 32. You need to put 0 here and obtain 0 here. Now let us put 1. If you put 1 here, then 1 into 1 is 1, which is minus 11. Minus 11 into 1 minus 11. So 6 minus 1, 5, 2. 25 is 25, 1 is 25. But you are not obtained 0 here, which is minus 32 plus 25 is minus 7. That means your 1 is not your required root. You need to go for 1 minus 12, 36 minus 32. Let us go to put 2 here. Then 1 plus 0, 1, 2 ones are 2, minus 10, minus 20, 16. 16 twos are 32. Minus 32 plus 32, 0. That means lambda minus 2 is your one of the factor of your cubic polynomial. That means lambda minus 2 into lambda square minus 10 lambda plus 16 equal to 0. Because already lambda is coming out from this cubic polynomial. So this will be the powers of square. That means lambda square, and this is the quotient of lambda, which is minus 10 lambda plus 16 equal to 0. Now let us find the factors of this one, which are 8 2s are 16, 8 plus 2 is 10. That means this can be written as lambda minus 2 into lambda square minus 8 lambda minus 2 lambda plus 16 equal to 0. And lambda is common in this one, minus 2 is common in this one. Lambda minus 2 into lambda minus 8 minus 2 into lambda minus 8 equal to 0. And lambda minus 8 is common in these two terms. That means lambda minus 2 into lambda minus 8 into lambda minus 2. So lambda minus 2 whole square into lambda minus 8 equal to 0. That implies the values of lambda are 2, 2, 8. These are the eigenvalues of the given matrix. Now let us find the eigenvectors corresponding to each eigenvalue. Let x is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 2. That is, ax is equal to lambda x, which means a minus lambda I into x equal to 0. That means you have to subtract 2 from the diagonal. That means 6 minus 2, 4 minus 2, 2. Minus 2, 3 minus 2, 1 minus 1. 2 minus 1, 3 minus 2, 1 into x1, x2, x3 equal to 0, 0, 0. What is this? This is homogeneous system. So let us find the rank of this matrix by reducing it into echelon form. So that use the elementary row operations, which are R2 tends to 2R2 plus R1 and R3 tends to 2R3 minus R1. Then this becomes no change in the first row. 4 minus 2, 2 minus 4 plus 4, 0. 2 minus 2, 0. Minus 2 plus 2, 0. Similarly, this row here also 0 into x1, x2, x3 equal to 0, 0, 0, which is in echelon form. And rank of this one is 1. Rank of A is equal to 1, but less than number of unknowns, which are 3 unknowns in your unknown matrix. Now you can say that the system has infinitely many solutions and n minus r linearly independent solutions. How can you find that solutions? Let us write the equation. 2x1 minus x2 plus x3 equal to 0. 2x1 minus x2 plus x3 equal to 0. As there are two linearly independent solutions, let us take two variables as constants. Let x2 is equal to k1 and x3 is equal to k2. Let x2 is equal to k1 and x3 is equal to k2. That implies your x1 will becomes 1 by 2 into k1 minus k2. Therefore, your x is something into k1 plus something into k2. That something is nothing but the coefficient of k1 in your x1, which is 1 by 2. And in x2, your coefficient of k1 is 1. And in x3, there is no k1, that means the coefficient becomes 0. Similarly, the coefficient of k2 in your x1 is minus 1 by 2. And in k2 is 0 and in k3 is 1. Therefore, the eigenvectors corresponding to the eigenvalue lambda is equal to 2 are obtained here. Now, let us find the eigenvector corresponding to the eigenvalue lambda is equal to 8. Now, let x is equal to x1, x2, x3 be the eigenvector corresponding to the eigenvalue lambda is equal to 8. That is a minus lambda I into x equal to 0. That means you need to subtract lambda is equal to 8 from the diagonal of the given matrix. So 6 minus 8, minus 2 and minus 2, 2. Minus 2, 3 minus 8, minus 5, minus 1. 2 minus 1, 3 minus 8, minus 5 into x1, x2, x3 equal to 0, 0, 0. Now, let us reduce this one into echelon form, which is homogeneous system of equations. That means R2 tends to R2 minus R1 and R3 tends to R3 plus R1. So no change in the first row. Minus 2, minus 2, 2. Minus 2 plus 2, 0. Minus 5 plus 2, minus 3. Minus 1 minus 2, minus 3. And similarly 2 minus 2, 0. Minus 1 minus 2, minus 3. And minus 5 plus 2, minus 3 again. Into x1, x2, x3 equal to 0, 0, 0. Now use this element and make this one as 0. That means R3 tends to R3 minus R2. So that minus 2, minus 2, 2, 0, minus 3, minus 3, 0, 0, 0 into x1, x2, x3 equal to 0, 0, 0. What is this? Echelon form, which is in echelon form, and the rank of the matrix is number of non-zero rows. Here you have 2 non-zero rows, rank is 2 but less than number of unknowns. That means the system has infinite number of solutions, and n minus r is equal to 3 minus 2 is equal to 1 linearly independent solution. To find that solution, let us write the equations. I am multiplying this one with minus 1 by 2. That means x1 plus x2 minus x3 equal to 0, and this is x2 plus x3 equal to 0. As you need to find one linearly independent solution, let me take one variable as a constant. That is that x3 is equal to k. That implies your x2 is minus k and x1 becomes minus x2 plus x3, which is minus into minus k plus k, which is 2k. Therefore, your capital X is equal to something into k is your eigenvector, which is the coefficient of x1 is 2 and in x2 it is minus 1 and it is 1 in x3. Therefore, 2 minus 1, 1 is the eigenvector corresponding to the eigenvalue lambda is equal to 8. This is the way to find the eigenvalues and eigenvectors of a matrix. I request you all, please like, share, comment and subscribe my channel Balaya Math Lectures Learn Every Step. Thank you.